Lesson 2-1, Properties of Numbers. We are on page 68 of your book. So there are 3 properties of addition and multiplication that we need to know. So the first property is called the commutative property. In other words, this is the flip-flop rule. And the commutative property says that you can change the order of the values in adding or multiplying, and it does not change the sum or the product. So, for example, you have A plus B is the same thing as B plus A. And the same applies to multiplication. So A times B is the same thing as B times A. So we can show this with numbers. We can say 6 plus 4 is the same thing as 4 plus 6. And in multiplication, 9 times 5 is the same thing as 5 times 9. So that's the commutative property. The next property is the associative property. In other words, you can think of that as the buddy rule. And the associative property says that you can change the grouping of the values when you're adding or multiplying, and it does not change the sum or the product. So the associative property has to do with parentheses. So we can group numbers in any order. So, for example, if we had A plus B plus C, A plus B is in parentheses, we can move those parentheses, and this would be the same thing as A plus B plus C in parentheses. In multiplication, we can say A times B, then times C, is the same thing as A times BC inside the parentheses. So we can move the parentheses put them in different places and still get the same answer. So an example for the associative property, if you had 2 plus 7 plus 3. You could also say that is the same thing as 2 plus 7 plus 3. Now we would do what was in parentheses first, and 7 and 3 make a multiple of 10. It is 10, so 10 plus 2 is 12. So we get the same answer either way. And then same thing in multiplication. If you did 9 times 4 and then multiplied it by 5, that's the same thing as saying 9 times 4 times 5 first. And you get the same answer either way. So the last property that we need to talk about is the identity property. And the identity property basically says how are we going to end up with the same original number in addition and in subtraction. So the additive identity in addition is 0 because any number plus 0 is the original number. So we know that A plus 0 just equals A. So for example, if we did 12 plus 0, that just gives us 12. In multiplication, the multiplicative identity is 1 because any number times 1 gives you the same original number. So this would be like saying A times 1 equals A. So 10 times 1 equals 10. So you have the commutative property, the flip-flop rule, the associative property, which is the buddy rule, and then the identity property, which is how we're going to end up with our same original number. Let's do some examples using these properties. So look at example number 1 on page 68 of your book. It says, Carlos rented a set of golf clubs for $7 and a golf cart for $12. He paid a greens fee of $23. Find his total cost. So we're going to use the associative property of addition, which is the buddy rule, to find the total cost in 2 different ways. So our numbers were $7 for the golf clubs plus $12 for the golf cart plus $23 for the greens fee. And so we can group this in 2 different ways. The first way is we can put the parentheses over the first 2 numbers. So 7 plus 12 and then add 23. So 7 plus 12 gives you $19 plus $23 gives you a total of $42. Okay, the other way that we can solve this problem is we can group our numbers differently. So $7 plus $12 plus $23. And let's group the last two numbers. So now we do 12 plus 23 first. That gives us $35 plus $7. That still equals $42. So either way that we do it, we get the same answer. So pause this video, do the quick check for problem 1, and then resume the video to check your answer. The quick check for problem 1 says you spend $6 for dinner, $8 for a movie, and $4 for popcorn. Find your total cost. Explain which property or properties you used. So I wrote out my numbers in the order that they were listed in the problem. So $6 plus $8 plus $4. Well, I then used the commutative property, so you need to write on the side which property you used only because it specified and it says to explain the property you used. So I used the commutative property first and I rewrote those numbers in a different order. That way I could put my 6 and 4 together because I know those are a multiple of 10. They add together to make a multiple of 10. So then I used the associative property and I put parentheses around the $6 and the $4. Then we just add within the parentheses, we get $8 plus $10, and then we add again to get a total of $18. So your answer should be $18, and you should have your properties listed off to the side, whichever ones you used to solve this problem. Okay, example 2 on page 69 says name each property shown. So letter A says 5 times 7 equals 7 times 5. Well, all they did was they flip-flopped the numbers, and so this would be the commutative property. The commutative property of of multiplication, sorry. Commutative property of multiplication and you have to specify if it's of multiplication or if it's of addition, because even though they work the same way, this is not an addition problem. So you need to say that it's the commutative property of multiplication. It's the flip-flop rule. So letter B says C times 1 equals C. Well, that is the identity property of multiplication. Letter C says 7 plus A equals A plus 7. So they flip-flopped the numbers. So that is the commutative property of addition. And then letter D says 5 times xy equals 5x times y. And so they changed what's in the parentheses, they changed the grouping. That's called the buddy rule. And so that's the associative property of multiplication. Okay, pause this video and do the quick check for problem 2, then resume the video to check your answers. Quick check for problem 2 on page 69. Letter A, you should have gotten the commutative property of addition because they're flip-flopping the numbers. Letter B should be the identity property of multiplication because you're getting the same original number in your answer. And letter C shows parentheses in different grouping orders, so you should use the associative property of multiplication. Okay, example 3 on page 69. When numbers are easy to compute mentally, we can use these properties along with mental math to find the answers. So in example 3, we're going to use some mental math along with our different properties to try to group things in a way that we can solve the problems mentally. So it says simplify 81 plus 6 plus 9. Okay, so when we look at these numbers, when I'm doing things mentally, I immediately look to see if I can make a multiple of 10. Well, 81 and 9 will make 90, which is a multiple of 10. That's an easy mental math problem. So I'm going to use the properties to put these in a different order and to regroup them. So I'm going to say 6 plus 81 plus 9. So I use the commutative property to flip-flop the numbers and the associative property to group them in a different way. So this is commutative and associative property in that first step. Then I'm going to add within the parentheses. So this would become 6 plus 90. So this is just adding. And then I add again to get a final answer of 96. Okay, pause this video to do the quick check for problem 3, letters A and C. Letters A and C on the quick check, then resume the video to check your answers. Quick check for problem 3 at the top of page 70. Letter A says 6 plus 7 plus 14. So I used the commutative property to flip-flop the order of numbers. Then I used the associative property to group the 6 and the 14 together. Then I added within the parentheses. 6 and 14 make 20. That's an easy mentally computable addition problem. And then 7 plus 20 makes 27. Then in letter C, you have 5 plus 12 plus 18 plus 5. Well, I can look at this and say, well, 5 plus 5 is 10. That's easy to compute, so I'm going to group those numbers together. Then you may see that 12 plus 18 also makes a multiple of 10 because the 8 and the 2 make 10. So this 12 and 18 added together is 30. So I used the associative properties and the commutative properties to flip-flop and group. So I grouped the 5 and the 5 together. That gives me 10. 12 and 18 gives me 30. Then 10 plus 30 is 40. So the point of this example is to use our properties to regroup the numbers in a way that we can do the math mentally. Okay, example 4 on page 70. Suppose you buy the school supplies shown at the left. Use mental math to find the cost of the supplies. So on the left, it looks like we have a package of graph paper for $1.65. Then we have a highlighter for 85 cents, and an eraser for 35 cents. So we're going to figure out what our total cost was of all the supplies. So looking at these numbers, are there any numbers that stand out as ones that easily can make a multiple of 10 in a sense, or can make an even dollar? Well, that's a little bit more tricky, because we're talking about cents now, but 65 and 35 will bump it up to the next dollar. So I'm going to group those two numbers together. So I'm going to rewrite this equation using the commutative property. I'm going to flip-flop the order. So now I have my $1.65 and my 35 cents beside each other. And so now I'm going to group those together so that I solve that addition part first. So $1.65 plus 35 cents comes out to $2. And then we can add in our 85 cents and we get $2.85 as our total. Okay, pause this video, do the quick check for problem 4 on page 70, and then resume the video to check your answer. In the quick check for problem 4, you're supposed to use the receipt on the right to find the total cost of the groceries. So I simply wrote out the expenses on the receipt in the order that they were listed. So $2.30 plus $1.80 plus $2.20. So I was looking at these numbers and trying to figure out which ones can I easily group together to do some mental math. Well, 80 cents and 20 cents will bump this up to the next dollar. So I have $1 plus $2, that's $3. Then the 80 and 20 make another dollar. So altogether that is $4. So now I rewrote my equation to say $2.30 plus $4, and I can easily add that together in my mind, mentally, to get $6.30 as the total cost. Okay, example 5 on page 70 says use mental math to simplify 4 times 9 times 5. Okay, so again, you want to look for numbers that you can easily compute together in your mind, which I know most of us know 4 times 9, but 4 times 5 is 20, so then I can count 20 times 9, we can count by 20s easier than we can count by 4 times 9 is 36 5 times, right? So we want to find a way to regroup these numbers to make it easier to compute completely mentally and not have to use our calculator. So I'm going to rewrite this problem using the commutative property of multiplication. And so we can say 9 times 4 times 5. Then we can use the associative property to group the 4 and the 5. And then we can multiply within the parentheses. So this gives us 9 times 20. Now if we count by 20s 9 times, 20, 40, 60, 80, all the way up and 9 times, you get 180 as your final answer. Okay, pause this video and do the quick check for problem 5, letters C and A and C. Again, A and C. Then resume the video to check your answers. Quick check for problem 5, letter A, says use mental math to simplify 25 times 3 times 4. So looking at this problem, you can see that 25 times 4, well, that's 100. That's an easy to multiply problem. So I rewrote my equation using the commutative property and I flip-flopped the numbers, so 25 times 4 times 3. Then I used the associative property to group the 25 and the 4. And then I multiplied within the parentheses, so 25 times 4 is 100, then times 3, and then I multiplied again to get a final answer of 300. Letter C says use mental math to simplify 2 times negative 8 times negative 15. Well, I don't know what negative 8 times negative 15 is in my head, and I know that if I do 2 times negative 8, that would be negative 16, and then I have to multiply that by a negative 15, and I don't know that in my head either. So I rewrote my equation using the commutative property, and I flip-flopped the numbers. So I put the 2 next to the negative 15, because that's going to give me negative 30, and then I multiplied times the negative 8. So then I used the associative property to group the 2 and the negative 15. And then I multiplied within the parentheses, so I got negative 30 times negative 8. So The reason why I can do this one mentally is because I can count by 30 8 times. 30, 60, 90, 120, 150, 180, 210, 240. Right, so you can count by 30s way easier than I can count by 16s 15 times. So we also know that a negative times a negative makes a positive. So our answer is a positive 240. The only reason you will have to write the properties is if they ask you to explain which property or properties you used. So if you have a homework problem that tells you to explain, then you need to write out to the side which property you use each time. If it doesn't ask you to explain, then you can just show your work and you don't have to list what property you used.